Make keeps things simple when it comes to cutting apart on an ROMAX abrasive Waterjet, but its true power lies in what is under the hood. One critical piece that comprises Make is the cutting model. The cutting model is responsible for taking various details about the cutting job into consideration, such as the quality of cut each entity in the toolpath is assigned, the composition of the material the part has to be cut from, the material thickness, the pump settings, and so on. The cutting model is responsible for helping Make determine how fast or slow to move around various features of the part, such as inside and outside corners. Make does a good job in doing so, with this particular part being cut in 1-inch mild steel. With the settings that are presently in Make, the job will take just over 17.5 minutes to complete, which is already faster and more precise than what most any other abrasive Waterjet could make this part in. The cutting model alone is not all that Make has in terms of achieving a quality part in the least amount of time. Let's turn on some cutting optimizations that are presently turned off to optimize how this path is cut. The various lead optimization settings allow the lead-ins and lead-outs to shrink or grow as needed to achieve the optimal length needed to pierce through the material by the time the end of the lead-in is reached, or have the jet clear the part when finishing a cut. Corner passing will add an additional length of cutting that goes beyond a sharp corner and then quickly return to where the part is cut to resume cutting the next entity. Doing this, as opposed to slowing down for a corner, can significantly reduce the amount of time to cut a part. IntelliCorner strategies improve the handling of inside and outside corners, achieving the best possible speed while maintaining the highest amount of precision for the corner. Finally, Tilt Forward, available only with the use of a Tilt-A-Jet, will have Make calculate the tilt relative to the direction of travel to optimize the jet so it has the least amount of a trailing lag possible. With all of these options turned on, and once Make recompiles the path using the optimizations, we can see that we now have a part cutting time estimate of just under 13 minutes. When you take the old time and compare it with the new time, you can see that it adds up to a savings of over 26% for this particular job setup. It is important to note that these settings are employed automatically for the user, without a lot of tweaking, experimenting, or specialized knowledge on the part of the operator. This added efficiency was achieved without the need to change any pump or nozzle settings, or the physical hardware for that matter, and are all provided for free as part of your premium software.